Galileo would take this to the next step because Galileo perfected the telescope, as you see right here. And when he looked through that telescope, he actually had a lot of achievements. We're actually going to only end with his noticing that his heliocentric theory, his theory that the sun is in the center. But before that, you should also know that he was the guy who realized that there were sunspots on the sun, that the moon had craters, that also the other planets had moons. He also realized that the sun was revolving on its axis. That was new, because that meant the sun was a changing body. And what else do we have? He also found the rings of Saturn, and he also found out that things on Earth actually don't fall at different rates; they fall at the same rate. He had a famous experiment where he went to the Leaning Tower of Pisa and dropped rocks of various sizes from the Leaning Tower of Pisa, and they fell at the same rate, he realized. So if you don't account for wind resistance, things fall at the same rate. So what's the basic point? Aristotle is wrong on so many areas. He's wrong about the heavenly bodies being made of another element. They seem to actually undergo the exact same changes we see down here. He's wrong about things falling at different rates. The world is being shaken. But then finally he has another idea. He decides he's going to prove that the world is heliocentric, and he uses math to do it. He actually applies mathematics to the this science, which is something we're used to, using math to prove things in physics. Now, his model is actually famous, of course, for saying the sun is the center, but he also clung to the circular orbits of Copernicus, which ultimately means his model is wrong, because Kepler was the guy who was right, actually. Kepler and his elliptical orbits actually got it right. But Galileo insisted on Copernicus's model, or at least his version of Copernicus's model, and he insisted on it so much that he said we should teach it as a sure thing. And that's ultimately what famously got him into trouble. You've all probably heard about the Catholic Church's condemnation of Galileo, and it is basically miscaricature, but here's basically how it happened. The Catholic Church told Galileo, don't be so sure about your model, because right now we have a lot of different models. The Catholic Church, by the way, was welcoming of different theories. They were welcoming of Copernicus, they were welcoming of Kepler. But what made Galileo different is he said he was sure. And, you know, it's okay to be sure, I guess, but one thing I remember is that he was sure about something that turned out to be wrong, and he kept insisting on it. The Catholic Church asked him to teach it as a theory. Why were they so? And then ultimately Galileo crossed another line when it came to interpretation. The problem is that Scripture got involved. In Scripture you have passages that seem to imply that Scripture at least intends that the earth is in the center. For example, Joshua 10:13, you have the sun stood still, which in the battle that Joshua had. And in that implies, of course, that normally the sun is the thing that's moving and the earth is standing still. Another place of the Psalms, you establish the earth not to be moved. These seem to imply a fixed earth that's in the center. And ultimately, the Catholic Church is like, it's okay to interpret the Bible allegorically, but you should only do that when you have to. You should presume the literal sense of the Bible and only change when you have to. So one thing the Catholic Church said to Galileo, St. Robert Bellarmine, whom we've actually probably heard of before in this course, St. Robert Bellarmine said to Galileo, it's okay to have a theory, but you shouldn't change the interpretation of Scripture unless we're sure. And the Jesuits are still working. Remember, there's Jesuits working at the Vatican Observatory trying to understand the skies. Once we know that the earth is not the center, then we'll understand Scripture allegorically. But in the meantime, we should just presume the literal. Galileo did not do that. He wrote a book called The Dialogue Concerning Two Chief Systems of the World, and in it he basically made fun of the Pope for allowing other theories and not clinging to Galileo's own theory. And the Pope got offended, and ultimately they did put Galileo in house arrest because he went against his promise to teach his own theory just as a theory. That's what he got in trouble for. He was not killed, he was not executed, he was only put under house arrest, and he was a little bit stubborn, really in your face about the fact that I'm right, ironically ending up being wrong. Nevertheless, this is the Counter-Reformation time. The church is kind of in fortress mode, and some people say that this was not typical of the Catholic Church at the time, which is normally welcoming of these things. A lot of this is admitted by secular historians too, is the brazenness of Galileo. But nevertheless, he did a lot. One thing we should emphasize with Galileo before we go on is that his main contribution is really not the heliocentrism, because Copernicus already did that and Kepler was more correct. The main impact of Galileo is he has literally turned the world upside down. By seeing those sunspots on the sun and those craters on the moon, The search for the particles that only move and cause all other changes by moving is no longer up in the sky. If those particles are out there somewhere, they're not going to be up above like the ancient world looked. They're probably going to be down below. So honestly, we're doing the exact same thing. We're trying to look for those things that only move and their motion causes all other changes. But we look down now. They looked up. And who did that? Who literally turned the world upside down? It was Galileo. That's Galileo's real contribution. Now, we still have a problem, though. We still seem to have these two worlds that follow two different rules. You have the sky world and the earth world. If only there were a way to unite both of these theories into one grand theory that explained the motion of the skies and the motion of the earth. And that would come with the genius Isaac Newton in his Principia Mathematica Philosophiae Naturalis, 1687. What was so great about this book? It was the law of universal gravitation. First of all, Newton realizes Kepler's right. Let's go back to the elliptical orbits of Kepler. But then also, this law of universal gravitation, what was so powerful about it is this one law that explains everything we see about bodies moving. Basically, the law was any mass attracts any and every other mass with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Or, mathematically, F equals G m1 m2 over d2. What this meant was that we had one rule that explained both why all things on the earth fall at the same rate and why things orbit the sky the way they do. It was so powerful. And it really started this revolution in science. If you dropped all the Aristotelian categories and dropped the Ptolemy and tried to use mathematics to explain things, you suddenly got more powerful accounts that explained everything. You didn't have to have a divide between the geometry and science. You didn't have to have a divide between the world of the sky above, astronomy, and the world of forces below. It was all one theory, and it was amazing. Once Isaac Newton did that, everyone tried to apply new ideas to science. You just unleashed, especially in Britain. Newton was British. Especially in Britain, you started to get all kinds of people putting forward new things. This is not, by the way, following chronologically. Francis Bacon was before Newton. But other examples, Sir Francis Bacon wrote his Novum Organon, which basically talked about the scientific method, a method of induction, not deduction, so not using logic so much as just observing things again and again and again. A method where you doubt the idols of society. What he meant by the idols was the things we tend to believe, tradition, popular opinion, things like that. And a method that he actually purposely contrasted with Aristotle. Aristotle's works on logic were called the Organon. Bacon's work was called the New Organon. He's explicitly saying to you by the title of his book, down with the past, down with the Aristotle. Now, he unleashed a scientific method. He's, by the way, the guy that would have died in the Guy Fawkes explosion if Guy Fawkes succeeded. But then we also have chemistry. Robert Boyle was starting to make new investigations in chemistry. That was new. Before this, chemistry and alchemy are actually the same thing. Robert Boyle starts to analyze substances and realize the way the phases of matter and things like that and make some great discoveries. He's especially famous for Boyle's law, that the pressure of a gas is inversely proportional to its amount, directly proportional to its amount, inversely proportional to its volume. And then you also had William Harvey, who figured out the circulation of the blood by being pumped by the heart. Before him, people thought the heart was the center of all motion in the body, and blood just carried a life force around. William Harvey figures out that it actually circulates. It comes back and forth from the heart. This is a big deal. And by the way, interestingly enough, he got most of his research by observing bodies during the English Civil War. He would show up at battles and just observe wounded soldiers. Now, as you can see, there's been a lot of progress in science, and it's all been done by doubting the past. Newton and Galileo doubt Aristotle. Robert Boyle doubts alchemy. Francis Bacon doubts Aristotle's logic. And William Harvey doubts Galen. Galen was a late Roman doctor, Hellenistic doctor, who said had a completely different account of what the blood did. Because of this, these are all British guys. England decides to invest in science. And so King Charles II, you might remember him, the party animal king, the Restoration, he founded the Royal Society. It was the first one of these. Other countries will follow, but the first institute dedicated purely to the natural sciences. And when he did that, he basically, it was a chance for people to work together to discover science. In Britain especially, the scientific revolution and enlightenment would take a more collegial character, the idea of working together. Now, one last thing I got to say before we close out the scientific revolution's impact is the motto of the Royal Society. You see its motto right here, and its motto itself is significant. The motto is nullius in verba, which means on no one's word. Right there, they're sending you a clear signal. In this new world of the scientific revolution, we are not going to trust anything because somebody said it. We're going to figure these things out for ourselves. We are now ready for the Enlightenment itself. Thank you very much.